Hello and welcome to this new video. Today I'm going to post my solution for the case of the Battle 2 of Road to Las Vegas series. The case is called Whodunnit by Harry Watson. I like this case a lot, honestly. I think it was very well designed, very interesting, also spot on in terms of, let's say, peak difficulty, with maybe some clash in results in the upper range, but considering the discourse we had during the battle, I think it was very well tailored. Unfortunately, I think a lot of solutions have already been posted. I have had the chance to look at a few of them. So I'm not sure I'm going to provide anything new in terms of approaches, but for the sake of having my solution as well in the channel, let's go into the solve. So basically, the entire case is based on this concept of coding and decoding messages according to some rules that you will have to consider during the case itself. The base logic is to shift the letters by a fixed amount, and this amount will become variable depending on the letter you're shifting of the word with the harder levels. Introducing also some weird symbols that you can see here. For example, this is for level 7. And the concept of sender and receiver of the messages that will encrypt the words using specific codes. Having said that, let's go into the solve. So level 1 is very easy. It asks you to go back and forth between the characters and the codes of specific codes of letters, numbers of letters you're given. So basically it's asking to convert, in this case will be the code of this, and the other way will be the car. So I will say if is number this, I'm going to do the car of this, otherwise I'm going to do the code of this, and that's it, I guess. Yeah, and here we go. Level 2, it's same thing, but asks you to perform Unicar and Unicode, and so it's a very it's a very small adjustment. And here we go. Level 3 asks you to shift this letter by a certain amount that can be also negative, and will wrap around the 26 letters of the alphabet. So I have a lambda to do this, which is called go around letter, and this is simply done with this function. Okay, level 4 asks for the same thing, but to be applied to an entire word. So what I'm going to do is a concat of my go around letter of splitter of this by this shift, and that's it. So I've concat everything into a one-shot formula. You can see right away that your results are probably correct, and they are. Okay, level 5 add me a bit, because let's say this kind of case is not exactly my comfort zone, so I struggle a bit with those logics. Probably overcomplicated my life during the live solve, because I built a two-way data table to address the options of the days of the week and the options for the ordinary shifts, because in this case you will have to apply a certain ordinary shift, and you are asked which ordinary shift you are going to apply, and you know that the first word of the sentence is a day of the week. So there's probably a better way to do this. Let's see. So example 5. Okay, so the sentence is this one. Input. So the first word is text before this, before the first space. Okay. what we can do is build a sequence of 26. Okay, so shifts, and shift this word accordingly. So will be again the concat of the go around letter of the splitter of this, lock the column over the possible shifts, and that's pretty much it. That's very interesting. Okay, didn't work with the array formula setup. Okay, let me shrink a bit. And the idea is to spot that, for example, here we have Sunday, which makes sense. So what I'm going to do is to say I want to is number. No, I'm not good with his number. If or this equals one of the days of the week, lock, then one otherwise 0. Okay, and so I'm gonna say that the shift is the x lookup of 1 into this, returning this. Okay, and I think that's it, because you also said probably that number and spaces should not be encrypted, so the decryption will be concat of scan nothing splitter of this, then lambda av if or v equals space or not is error number value v, so v is a number. In this case it will be v, otherwise it will be go around letter v by this shift, and hopefully yes, apparently it's correct. And you are asked to find the last word, so actually last word will be the text after this, after space -1, so last distance, which is the word case, which matches the example. Need to adjust my microphone a bit, and yeah, so I've used all the inputs. Let's scale the solution. Okay, for some reason during the battle I got errors here for three games that I manually solved instead of fixing the logic, because I was probably messing up with spaces or number or whatever. Lost probably 1 minute per case, which is a good 3 minutes that I could have used to first of all fix everything, because I didn't fix this one, and also pause with some spare time in my time bank, but that's okay. Level 6, I found it easier for me, because it applies the concept of a long shift. So basically each word is not only shifted by the fixed amount, but also this variable amount, which is 0 for the first letter, then 1 times the long shift for the second letter, then 3 times the long shift for the third letter, and so on. So example 6, here you're given the weekday, and I think the from to, yes, sender recipient, and so those are the values. So basically There is no such thing as the first word. You need to find the shift, and you need to find the long shift, because then I will need to apply here the codes before the letters. So transpose, splitting the first one. I think here we are using Unicodes of this. Okay. And we will have the shifted codes. We will have the results here. Okay. In terms of finding the shift, you will have to match Olivia and David in this case. So I'm going to build an index X match approach on this grid. X matching 1 over the rows lock, X matching 1 over the columns lock. What got me is that the sender is on the rows, so this, and the receiver is on the columns. Okay, so 5249 matches. The along shift will be the X lookup of the weekday. Here returning those codes. Fantastic. I need the position -1, which is sequence of rows of those starting from 0. Okay, so shifted will be my codes plus the shift plus the along shift times this, and so I will use the unit chart of this to find the results. Seems right. So I'm going to concat, and I think we should be good to go. Yes, we are. Okay, so there's no way to tell if those are correct during the solve, but I mean, those kind of make sense because you can see numbers here, full symbols there, so it seems right. Okay, that's where I got during the day. Then I had a look at level 7, decided this was not going to be the day to make it, and went on the bonus questions. But for the sake of posting the walkthrough, let's provide a solution for level 7 as well. So okay, level 7, it's a bit tricky because also there is no direct correspondence between the games and what you need to do actually. So let me grab the messages here. So basically here you're told those are the 30 messages sent. Each message begins with the day of the week, and the logic for the along shift is the same of level 6. You need to find basically that day of the week to figure out what could be the ordinary shift and the along shift. With the ordinary shift, you can also find who exchanged that message because those are unique codes. So basically, you can understand who is the sender, which actually is the ultimate question to be answered. So those are the messages. We know that the first word is the day of the week. What I noticed when I thought about this case is that if you look at the length of the days of the weeks, you can see those are not unique, unfortunately. So I thought I had a great idea in mind, but I had not actually. But if you combine also the first letter, the combination of the two is unique actually. And I think this is the same approach that Elliot did. So that's the same way I approached level 7. And I've seen the video of Elliot later on. So this is a unique list of options. So what I could do is first symbol, take the left of this. Okay. This first symbol has a corresponder Unicode, which is this. And the key idea here is that the first letter does not shift it because it has an index of 0, so you only apply the ordinary shift, which is a huge help in this case. Okay. Okay, so what I can say is, let's assume I have those 7 different options, which is options, it will be a transpose of those letters. Okay, which come with different Unicodes as well. And so if I take out those actually should be the possible ordinary shifts that I have, which actually are exactly those values where I want to filter out everything which is not empty. And so what I can say is if or can I say like is number X match those? I'm not familiar with his number at all. Here. Interesting. I like to work with numbers. Okay. So options will be to filter this according to this equals 1. I need to lock. Okay, so we can see that actually we have different options. Maybe let's throw in a unique because I don't need duplicates, of course. Okay. I also need the length of the first word, so len of text before this space. So option with length, it's this and this. Okay. Valid options will be a filter list. Thanks Elliot for the lambda, which I want to filter with those. Okay, unfortunately I still have some double options here. And now I can find the shifts. So shifts will be X lookup of this into into this, returning No, no, no. So the shifts will be the X lookup of left of this into those, returning those. Okay. Weekdays, X lookup those into come on, into those, returning those. Sorry, those are the long shifts, and that's basically it, because at this point I could say I want to index this according to this. Weekday, I don't need it. Shift, I wanna index this according to this. And long shift, I wanna index this according to this. Okay. Okay, the position, and so minus. Okay, Friday committed. Okay. If this equals 32, otherwise this. Can I just say if error this? Okay, so we actually have our meaningful sentence. So I can say sequence of 30. I can take this and I can scale it. Except this one, which is this. So probably 8, 5, 6, 9. So why just I don't reverse it and reverse also this. Okay. So those are my 30 messages. I'm a bit lost. Okay, now I need to check Where are those? 30 messages, 30 shifts, and for each one I would like to find this in the people tab. Okay, I'm interested in the sender, which is row 2, so it will be left of this and 2, and simple indirect of people and this. Fantastic. Now I just need to associate those with the transpose of these sentences and the transpose of the sender. So is number, find this, lock into this, lock the row. Minus minus. Okay, and then I want to X lookup 1 into this, returning from this. And hopefully that's correct. It is. Okay. Quite a long time. Luckily the bonuses are quite easy, so convert all characters given in level 1 and 2 to their corresponding code unique numbers. What is the arithmetic mean of all the Unicodes, including the originally given Unicodes? That required me to do that a couple of times to be sure. So what I understood is Unicode, because the problem is that if you do a Unicode of 73, you get a different thing. So I did, I think, is number. No. Then this. Otherwise, Unicode of this. All characters given. And the average is 2261. Okay. What is the most common ordinary shifts in level 3 and 4? Note that, for example, a shift of -1 is equal to a shift of 25. So level 3 and 4. If this is greater than 0, is this, otherwise it's 26 plus this. -1, okay. Boom, and then I run the lambda occurrence count. It asks for the most common ordinary shift. Reading comprehension. Okay, that's my weak point. On the correspondence tab, determine the Unicode numbers of all the symbols. What is the sum? So sum of Unicode of splitter of this, including spaces. Yes. So sum of this. Okay, on the people tab, what is the maximum shift between any given pair of people? Amelia to Benjamin. Okay. Benjamin to Amelia. To call this and this and this. Okay. So text split this over this. So let's look up this and this here, lock, returning here, lock. And then we have if error. I don't know if that's with the absolute value of not, but I checked that it's the same thing. It asks for the maximum shift, so I'm going to put to 0 otherwise. So apparently it's this one. It is. On which day did the most crimes occur and how many times it appeared? So let's look up those options into my option list lock, and I want the day. Tuesday 8. Okay, yeah, I think that's it. Again, it was a super case, level 7 on the art side, to be honest, to be solved during the live stream. So the live solve. There were for sure smarter approaches. For example, noticing that if you calculate the difference between the codes of each letter of the day of the week, you get a signature, how Diarmuid calls it, and I suggest to check out his channel to see more about this solution, which is a very clever shortcut to be spotted, and that for sure will simplify things a lot, to be honest, compared to running this kind of exercise in which you also have multiple options, which doesn't help for sure. And probably there will be other many options which are really strong to approach this level. Having said that, I hope you enjoyed my solve. Let me know what you think in the comments, and we'll see you in the next one. Bye.